All right, y'all, so we want to take a look today at substitution. So we're going to be solving systems of equations. We did this previously on a graph, but now we want to do this algebraically. So one of the ways that we can do this is with a pretty simple idea in mathematics called substitution. Basically, the idea is that if we know that two things are equal, then we can interchange them whenever we want. So in this example here, we have these two equations in the system, x equals 2 and y equals x plus 10. So right off the bat, with this pretty simple example, we know that x and 2 are the same thing, meaning that anytime I see an x, for example in this equation, I can replace it, or I can substitute it with a 2. So let's try that out. So I'm going to write this second equation again, y equals x plus 10, except instead of x, I really want to write 2. All right, we just proved that x and 2 were the same thing, right? That's given to us right here. So that means y, if x is 2, y is equal to 12. Great. So this system, right, this system right here is solved at the point 2, 12. Okay, if we were to graph these two equations, we would see that intersection point at 2, 12. Cool, let's take a look at another one here. So this one's a little more abstract. Anytime we have an x, we could replace it with an a. So if I were to rewrite this equation, I can just replace the x with an a. That's the general idea, right? So it doesn't have to be constant necessarily. We can replace variables if we know they're equal to each other. In this one, we have x is equal to 3y's. So this one's a little more complicated, but again, just anywhere we see this x, we're going to replace it. So I'm going to leave a space for that x, and I'm going to put parentheses where that space is. It's a good idea that anytime you are substituting, save for very, very simple examples like this one, anytime we're substituting something into an equation, we want to use parentheses. So I see that x is the same thing as 3y. So where I would normally write an x, I'm going to replace that with 3y. Now we have an equation here, this guy, that we should be able to solve because there's only a single variable. So let's take a look. We've got 2 times 3y, that's 6y, minus 4y is equal to 22. Now we can combine like terms. 6y minus 4y's is 2y's. If 2y is equal to 22, then y is equal to 11. Right? We just divide by 2 there at the end. All right, so let's look at some slightly more complicated examples, and these are the kinds of problems you're going to see on your practice. So this one's pretty similar to the one we did before, but this time, instead of substituting x, we're substituting y. It doesn't really matter which one. So again, we have this given, which is y is the same thing as 6x. We can rewrite the second equation, 2x plus 3y, except I don't want to use y. I'm going to be replacing y with something I know that's equivalent, in this case, 6x. So because I know those are the same, I can replace y with 6x there. Cool, cool, cool. All right, so now we got 2x plus, this is going to be 18x, right? 3 times 6 is 18. So 2x plus 18x is 20x. Skipping a step there. So 20x is equal to negative 20. We don't want 20x's though, we just want a single x. So we divide by 20. We get x is equal to negative 1. Again, right here, I'm dividing by 20 to get rid of this. I got to do it to the other side as well. Cool. All right, let's try another one. And these are going to get a little more complex as we go. All right, so this time we have y equals x plus 9. And then our second equation is 3x plus 8y equals negative 5. So again, I'm going to start this out the same way. And I already know what y is equal to. So I have a plain y right here, and that's equal to x plus 9. Right, I already know that. So I'm going to use the other equation, and I'm going to replace y. I already have a simple expression that I know to be equal to y. Again, color coding here. We know that y is the same thing as x plus 9. So again, instead of putting y here, I'm replacing it with x plus 9. All right, so now we can simplify. So we know we want to distribute first. Remember, you always distribute when you begin solving here. We got 3x plus 8x plus 9 times 8 is 72. It's away from my face here. All right. So we got 3x's plus 8 more x's is 11x's plus 72 equals -5. Sorry about my handwriting, y'all. All right, I want to get all the constants on one side of the equation. So I'm going to get rid of this 72. I don't want 11x plus 72. I just want x. I'm going to isolate that x by doing the opposite or the inverse operations. So instead of adding 72, I'm going to subtract 72. And because I did that on the left, it needs to happen on the right as well. So just to kind of make this a little more clean, we've got 11x equals -5 minus 72 more. That's minus 77. All right, if 11x is equal to -7, then we're going to divide by 11 to find out that x is equal to -7. Cool. So we've been solving these, but we haven't really been writing out our answers. So on all of these questions, remember that ultimately what we're looking for is a point of intersection, right? Like we said back here, the place where these two lines intersect is at 212. So on all these problems, my answer should be a point. So let's go back and fix that because we haven't been doing that. So my final answer here is not just y is equal to 11. I need to know what x is as well. So we always answer these questions with a point. Again, we're looking for the solution to both equations, which is a point on the graph. So we know y is 11, which means that x is 3 times 11. So x is 3 times 11, which means x is 33. So the point of intersection is going to be at 33, 11. Well, let's finish off these other ones we were looking at. We got y is -1. X is -1, so we have the first part of the equation. To get y, we need to plug it in. This one I'm just going to do in my head. So 6 times -1 is -6. Cool. It's nice to show you plugging that back in. Basically, we're substituting again, putting x back into here to figure out y. Sweet, 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 sweet. All right, so we were here. Sorry about that tangent, but I forgot to do the point thing. We have x. X is -7, so that's the first part of our answer. Now we have to get the rest of the coordinate. What is the y piece? All right, what is the y coordinate? So let's go back to here, and we're going to plug -7 in. So it says y is the same thing as x plus 9. Y is the same thing x plus 9. And then x is the same thing as -7. So using that substitution idea, we can replace x with -7, and we'll find that y is equal to +2, my bad. So -7, 2 should be the point of intersection. And if you want to prove it, right, and this is going to be really useful when you're doing your practice, if you want to check your answer, throw these into Desmos, right? Graph these two equations and see if they intersect at this point. They ought to, unless I messed up. All right, one more, and this is where things get a little more complicated. So in all the other examples, we started out with y equals something, or x equals something. We don't have that here. There's no variable standing by itself next to an equation. So we've got to make that happen. Okay, we've got 2x plus y. Come on. 2x plus y equals 9. But we don't have y by itself, so we need to force that to happen. So what I'm going to do is I'm going to take this equation and I'm going to solve for y, meaning I'm just going to get y by itself. All right, so we've got y plus this other junk. Let's move that other junk. We don't want a plus 2x, so we use the opposite, subtracting 2x, to kind of force it over to the other side of the equation. All right. So these two equations, the one I've just written here, y is -2x plus 9, and 2x plus y is 9, these are the same exact equation. I've just changed the form of it a little bit. Now the reason I'm doing that, because now I know what y is equal to. I don't know what the number is that equals y, but I have this expression that I know is the same thing. So if y is equal to negative 2x plus 9, I should be able to go back into the other equation and replace y with that. So let's try that. All right, so I'm going to take this top equation, 2x minus 3y equals negative 11. So you can see how much kind of pencil and paper work this is, which means I'm going to really need you to show your work on this assignment, which you can do it on paper and upload a picture is probably the easiest way to do it, or you can use something like this that I'm using here. All right, so I know that y is the same thing as negative 2x plus 9. So you notice I dropped out the y, and I'm going to substitute it with something that's the same thing. So our substitute for y is negative 2x plus 9. Sweet, so now we have an equation that's a little ugly, but we should be able to solve it. We have a single variable, just my x, and we can figure out where to go from there. All right, so I got 2x minus 3 times all this. So again, we start by distributing. So I distribute that negative 3. 2x, negative 3 times negative 2x becomes positive 6x. Negative 3 times positive 9 becomes negative 27. And then we have equals negative 11. All right, let's do some cleanup. 2x and 6x makes 8x. Write everything else. Okay, now I want to get all the constants over on the right side, all the numbers over on the right. So I'm going to add that 27. Hopefully this part feels real familiar. You guys are pretty good at solving equations at this point. 8x equals 27 minus 11 would be 16. All right, we're close. 8x is equal to 16. So if we divide by 8, we get x is equal to 2. Not like me writing down there at the bottom. All right, so x is equal to 2. We're not done. We have part of the answer, but remember our answer is a point. The solution to the system is the point in which those two equations meet. So I have the first part of the answer. So I know that I'm going to have 2 something, right? There's some y coordinate going to work for me. So to get the y coordinate, I'm going to take this x value and I'm going to plug it back into one of these equations. And it really doesn't matter which one I plug it into. I should be able to solve it either way. So I'm just going to kind of look through and find the easier looking equation. This bottom one looks a little easier, and actually, I'm going to use this form. It doesn't really matter, right? I'm going to use this form that we already have down here because it's a little simpler. We've done some of the work for this. Okay, are we seeing where I got the 2 from? 2, same thing as x, right? We proved that over here, that x and 2 are equivalent. Anytime I see an x, I can replace it with a 2. All right, so y equals negative 4 plus 9. So y is 5. Let's finish off our answer. The point of intersection is at 2, 5. All right, before we wrap up, I want to, real quick, just prove this. Let me get out of full screen here. Not what I wanted. So if we throw these equations into Desmos, we should see the exact same answer. So I really, really encourage you to do this when you're working on your, when you're working on your assignment, use Desmos to check your answers. You shouldn't have a wrong answer, right? You should be able to plug it in and check. And then if something's wrong, you can go back and try it again. So do 2x. Trying to do too much at once. All right, so it looks like we should have an intersection at 2, 5. And that's what we got here. Cool. So again, Desmos is definitely an easier way to solve the equations. There are a lot of situations where we don't have a nice pretty map to work with, or a graph to work with. So it's really useful to be able to learn how to do this by hand. Again, you should be able to verify. Feel free to use Desmos to check your answer, but I am going to want to see your work, something similar to this. And you can do it on paper, or you can use a whiteboard like this. So you'll have 1 or 2 that are this difficult. Most of them will be a little bit more easy, where we have one of the variables already solved for us. Thanks, guys.